Good morning, everybody. This is Carl Griffith from Graybar, and I want to thank you for joining us on our G2 Talk webinar series today, where our discussion is going to be branch monitoring and power monitoring. So before we get started, though, I would like to give you a little bit of information about Graybar and what we're about. Graybar's mission statement is that we help our customers power, network, and secure facilities with speed, intelligence, and efficiency. And today, that facility is the data center, and we're going to talk about power inside the data center. Before we get started, a couple things that I would like to remind you about. This is be a 30-minute presentation with a 10-minute Q&A at the end. If you would like to ask a question at the end of the presentation, there's an icon at the bottom of your screen that says QA on it. If you'll click that, a little dialog box will open up and you can type your question in there. We can see those questions you type in at our side, and we'll respond to those at the end of the presentation. We'll try to get through as many questions as we can. If you're one of the first 50 people to log on and register to become part of this, or actually live on this, the first 50 to be live on the presentation with us today, we're going to send you an email for a cup of coffee. And so keep an eye out in your email today or early tomorrow, and you can exchange that email for a cup of coffee from a large coffee chain here in the United States. All the presentations that we do on the G2 Talk webinar series are archived on Graybar.com. All you need to do is go to Graybar.com to the home page. You'll see a G2 Talk logo. Click on that, and there'll be some links to take you to the archive. So if you'd like to see this presentation again, if you would like to get a copy of the white paper, you can get it there, or if you'd like to share it with your colleagues, we'd welcome you to do that. Our presenter today is Mark Walter. Mark Walter is on the energy side of Schneider. He's with Energy Solutions, and I've known Mark for quite some time. We've been crossing paths in the data center space probably for maybe 6 years now. I think I may have first met him at 7x24 or an Uptime Symposium or something like that. Mark is definitely a subject matter expert when it comes to power monitoring and metering inside the data center, and we're just very, very fortunate to have Mark with us today. So I'm going to pass the baton to Mark, and we'll go forward with our presentation today. Thank you, Mark, for joining us.
Thank you, Carl. Yes, my name is Mark Walter, and today we're going to be talking about reliability and energy efficiency within the data center space. When you look at data center applications, they really break down into 3 areas. One is branch circuit monitoring within typically like the PDUs. Also, data centers are very interested in power quality. We have a nice solution with our power quality metering and our satellite event recording systems. And always customers are interested in their usage and how they keep the energy system green. You know, one of the things that we're looking at when you're putting in a monitoring or metering type system is there's 3 attributes. The first one is you're trying to help a customer with their system reliability. Do they have any alarming? Do they have timestamps of what might be any root cause problem so they can get to what might be the situation? And can you get to, understand what maybe was the status of a breaker, the status of a UPS system? The second thing is obviously data centers grow, and what you're trying to do is be vigilant of the space and the load growth within the data center. Also, a lot of systems have redundant A and B circuit loading, so what you try and do is maintain the fact that your systems are balanced, and you try and have a good trend and capacity so that you can have tools in place to provide a window for the operation system to understand your system capacity. And last but not least, data centers are a huge consumption of electricity, so what we're trying to do is help that data center operator spot inefficiencies, provide some sort of measurement tool like PUE, and also provide information that they can actually benchmark their data centers. Typically right now we see Energy Star as kind of like the lead ship in that sort of performance metric. So one of the things that we're looking at is talking to data center customers about what sort of monitoring system you can put in. And PowerLogic in our StructureWare system really is for a lot of systems. So you can basically directly connect your electrical distribution, your PDUs, your craft units, and those will be talking like a Modbus, PCP or TCP, or SNMP is the typical one we've seen. Also, you can do connected devices like a generator control, or you can actually have some status devices. So typically, people might be bringing in a fire alarm, a leak detection. These would typically talk to some sort of remote client or talk to like a redundant server. There's a lot of third-party devices that typically you want to monitor with a monitoring system. You could monitor like the protective relay within your switchgear. You could monitor the PLC device within your generator control, battery tech monitoring. Obviously, you're looking at an overview or input from your UPS, leak detection, ATS systems. And of course, the branch circuit monitors are the base of some of the real-time energy information coming into your systems. So let's talk a little bit about branch circuit monitoring. This is a picture of a PDU, and really what we're looking at is a lot of systems, especially in the retrofit area, don't have branch circuit monitoring. Typically what you're looking at doing is you're looking at monitoring the mains, and you're looking at monitoring each branch circuit. In the past, a lot of people would use an old-fashioned device that maybe was a clip-on meter. But what we're really looking at is in a retrofit application coming in with a split core type CT, so you could actually do a hot installation, and we could actually allow a customer to do energy cost allocation and real-time alarming for around $100 a circuit. Here's a typical picture of what a BCPM installation would look like. If you look at the beginning, you would probably use low voltage CTs for looking at the mains. Then you would have typically a 50, 75, or 100 amp branch score CT. And then in the bottom, typically you'd have some sort of control device that would be monitoring a typical 42 circuit panel. So here's some of the dilemmas. Right now, a lot of circuits in the PDU is a typical 20 amp circuit. And by rule, you can only load a 20 amp circuit 80%, which would be 16 amps. However, most servers use a redundant system using two power supplies. This is known as a dual corded system, which means within that PDU you have two circuits feeding the same rack. These circuits are known as rack A and rack B, which would share the load. Should breaker A trip, the load will obviously shift over to load B. That means that for an entire load, both A and B circuits could only be loaded to 50% of the 80%. So one of the things that we're trying to educate the market and also maintain that path for the customer, in other words, a 20 amp PDU circuit can be only loaded to 80 amps and still maintain code with the redundancy that we put in the data center space. You know, the data center staff know this. So what they typically do is as the loads of the data centers are expanding, changing, they're going out and manually measuring this. And with a lot of the things that we're doing with NFPA 70E and a lot of the things that, you know, periodic readings don't provide enough information, especially if the loads are changing. So what we've seen is customers are looking at existing applications to go out and actually move away from manual reading and go to installed metering. So what are some of the products that we have for installed metering? This is a typical branch circuit monitor. It can monitor up to 84 circuits. This one has basically electrical measurements of energy, power, current, also gives you some power quality. This branch circuit device is for general applications. It talks Modbus RTU, and as you notice, it has a accuracy of about 3 to 4%. What we're starting to see is a major trend in the data center market. Our customers are going to colo. So if we look at another meter type, this meter type also monitors up to 84 circuits. But if you notice, we're starting to get into that accuracy where that customers can do sub-billing and sub-metering. So typically you're looking at accuracy of 1.5 to 1% is where you're looking at. You still have the same sort of electrical measurements. What also we start seeing in a trend is Ethernet communications as standard. Additionally, customers are looking at using SNMP as a output device. So what we'd like to show here is a couple of examples of where we're actually monitoring or actually mounting enclosures. Typically, the branch circuit monitors are near a PDU, so typically they could be mounted in enclosures next to the PDU, on top of the PDU. Here's a picture of a typical PDU. As you can see, they're mounted on top, and the BCBM boards are in the back. This is a application that we've used with a number of customers. Another thing on the top is we can get a separate enclosure. So what we'll do is we'll actually use like an OEM interior, and we'll mount the split core CTs in the panel boards, but then we'll bring these basically up to a top-mounted rack. I would say this is where I see most of my applications. Customers still tend to do a lot of enclosures floor-mounted. They'll have a raised floor within the data center, and they don't have either the wall space or the space on top of the PDU, so we'll go with a floor-mounted enclosure. Here is an example of a project that we did in Kansas City. We actually were able, without a shutdown, to do 5,300 circuits. What was kind of neat is, obviously we had a very small maintenance window, so we had the enclosures put in place, we had the shutdown put in place, so we can react in a very timely method with our services group and our things that we can do as an application and work in a very condensed window to get metering up and while not taking the data center down. So here's another application that we did, and you know, this is a customer, and here's an application where we're actually showing that colo application of energy peak power, and we're actually providing something to a data center for energy allocation. And this is using our branch circuit monitoring. We're monitoring alarms, and we're providing both capacity monitoring and energy billing. So now we're jumping on to probably something that is very key in addition to energy efficiency is power quality, power reliability, and putting in a device called a satellite or a sequence of event coordinating system. So one of the things that we do is we make a lot of power quality meters, and within those power quality meters, if there's an event, if there's an alarm, if there's a trip, we have the ability to do a waveform capture. And a waveform capture is like taking a picture. The more granularity that you have on the picture, the more slices of the sine wave, the better the resolution. So as we're showing in this picture, the more snapshots that we get of the waveform capture, the better that we can get the resolution to the event. Here's kind of where a typical one line of a data center looks like. Typically you'll have a power quality meter in the main switch gear, but also we want to also understand what might be some of the applications of having some information downstream in the sub-metering. So if we would have a power quality event, as you see, we can capture waveform information, basically talking about A, B, C waveform captures, and that's very critical on the power quality meter on the main. However, it's also very important that we capture waveform information in the output of the UPS, because a lot of people will put it in, have that capability in the main switch gear, but again, when we're looking at an event and we're trying to understand directionality, it's good to have it here on the output of the UPS. Here's some of the things that we can provide. What you see when we're doing our waveform capture, and you look at these waveforms, we're date stamping it, we're time stamping it. We have a patent on how we actually do our waveform capture, so it's very accurate, and this is actually things that you could take back to your utility for a power quality event, and it's good resonance for that. The other thing that's very important is within a data center, you're looking to understand, did the event or did the action or the alarm come within the device? So basically we can look at if you look at the waveforms and the positioning, obviously here you're looking at an upstream event that could be weather, grid related, something that happened outside of the data center. If you look at the other event where you see the voltage and the amps, that typically might be something that we're reading off another power quality meter. That's a downstream event. That's why we want to basically make sure we're looking at that UPS, so something inside the data center. So again, we can do a good job of disturbance detection, which gives you that pathway to understand where your application occurred or the event occurred. The ultimate solution and the ultimate scientific tool that we've come up with in reliability monitoring is to use the satellite technology that our Defense Department put into space, GPS time-stamped sequence of event recording. Here's some of the interesting facts. Thanks to our taxpayer dollar, literally we have this free service that we're using for time stamping. We're using for a lot of things in our computers. Basically, the atomic clocks and the satellites are so close that literally you're accurate to a billionth of a second in some of the GPS satellites. So with that investment out in space, we've devised some equipment that can actually utilize that to give that investigative tools within the data center. What you typically find within a data center is your UPS, your CRAC, your ATS system have clocks. So if you would have some sort of event within a data center, you'll have a clock timestamp within one of these devices. However, none of these clocks are synced to each other or to a trusted standard. Also within a data center, you'll have billing automation systems, but billing automation systems are not totally real time and can't do some things that are within this power quality or power reliability. So one of the things that we've found is that if you have a large distributed data center, we found that as you start moving up in your reliability system, this ability to use sequence of event fault recording is really a key diagnostic tool to increase the reliability and the stability of your system. So here's a couple of things, as far as inputs. Typically we look at high voltage equipment, protective relays, ATSs, PDUs. We're looking at putting some devices on the generation bus. And typically our motto is if it moves, changes states, has the ability to provide an alarm, we want to be able to capture that event and put that event in a chronological sequence. So here's a little bit of a waveform capture upstream, downstream of a UPS. So if we would have an event, obviously you'd see the trip at the main switchgear. You might have a breaker event. What we would do is then that would generate alarm that we would capture in the sequence of event recorder. You might have an ATS transfer going to your parallel system. We would capture that sequence of event. If you would have maybe instead of a trip upstream, you have a trip downstream at the UPS, we would capture that alarm and date stamp that within the system. So now I have a total date stamp, and I have the ability to look at whether I'm going an upstream or downstream application within the UPS. Here's just a snapshot of what that looks like as far as, a typical event. And On the bottom there, we just kind of did a brief snapshot scenario. Generator 2, we had a frequency alarm, UPS switch to bypass, static switch did out of sync alarm, and then we all timestamped that so you could see as that fault and as the alarming went through your system, how did all those systems from a reliability and sequence handle the event. So basically, in a nutshell, what we've created is a flight recorder. So if there was any situations that we have a total diagnostic tool to go in, recreate the opportunity, recreate the incident, and determine what happened. So we've talked a little bit about branch circuit monitoring. We've talked a little bit about power quality. And one of the other things that having a metering system and a monitoring system in a data center is it gives you those tools to actually help a customer understand their power utilization, or as we affectionately know as PUE. This slide here talks a little bit about the losses and the loads within a data center. So literally, if you look at a typical data center, IT equipment on average is about 56% useful work. What you're looking at as far as losses is lighting 1%, the crack in the cooling units and stuff like that, you're looking at upwards of a 30 to 33% loss. You have some inefficiencies in the transformers and PDUs in the 2 to 4% range, and we've seen losses in UPSs depending on how they're constructed in the 5 to 6% range. How do you calculate PUE? PUE is basically something that third parties have put together this table. We tend to, again, see Energy Star as actually promoting some benchmarking, but PUE is basically total data center load divided by IT load. So if your data center, in this example, uses 1,625,000 kilowatt hours, your IT load is 1.3 million kilowatt hours, your PUE for this sort of application would be 1.25. What is key and kind of dovetails back to what we were talking about before as far as branch circuit monitoring is if you're going to accurately measure PUE, where would you put your metering? So we suggest that for a data center, you want to basically put your metering on the utility input, the UPS output, the PDU output, and also your input to your server racks. This is kind of a physical documentation of what we just showed there with the metering shown on the various output points and inputs. One of the things that is encouraging is PUE is improving. Here's a chart basically that shows how PUE has changed from 2007 being closer to a little over 2. 2009, it's moving to 1.87. What we've seen on average, and this is based on some information that we got from the Uptime Institute and the Data Center Research Group, is average PUE in 2011 is 1.8. So as you see, we've raised our benchmark from 2007, but what we've started seeing 2011, 2012, 2013 is a little bit more of a leveling off at the 1.75, 1.8 area. So one of the things that we looked at and got some other third-party information is on what is a good PUE. So according to the EPA and to Energy Star, basically they set a minimum rating of 75, so which is an equivalent how they turn their numbering system into PUE of about a 1.62. So this is from a Energy Star perspective, a 1.62 is where they've basically established a benchmark. So there's a little bit of delta where the average data center is versus where we see the typical good thing by Energy Star or the EPA. So in total, that's sort of a little bit of a snapshot of what we've done from a branch circuit monitoring, a power quality standpoint, and also some information in regards to calculations of PUE and some of the benefits of having an installed metering, monitoring system. And I think these trends are very important as data centers move into a lot more colo applications where billing, sub-billing, and tenant metering become much more important. So we'd like to open it up to any questions.
All right, Mark, thank you very much for your excellent information here. So we'll go through our Q&A right now, and we have a few questions that have already come in. The first one's from Robert. Robert wanted to know about how to download the slides or get a copy sent to him. Robert, we've captured that data. We know who you are, so we'll send you a copy of those slides. For everybody that's online, you can go to graybar.com and click on the G2 Talk webinar logo, and you'll see a pathway to the archive where you can review the presentation. If you actually like a hard copy of this presentation, if you'll just get in touch with your Graybar sales representative, they'll get to you with a copy of the presentation, or you can contact me, Carl, K-A-R-L, .griffith@graybar.com, and I'll be happy to send you a copy of the presentation. Another question came in from a government, Jonathan, who works for the government, Mark, and he was wanting to know about TAA compliance so that products can be used in a government application. So his exact question is why don't you make APC equipment a TAA compliant country so that he could use it? Do you know anything about that?
I actually do not, Jonathan, but we do have some APC people here. We do sell a lot of APC equipment to the U.S. government. I know they ship it overseas, but for that question, what I'd like to do is get back together with Carl and get you an information and get you back, because I don't have that detailed information with me, but I'd be more than happy to get you an answer back there, Jonathan.
So, Jonathan, we've captured that question. Just so happens that Mark and I are with some APC people today, and we'll respond to that to you via email. While we're waiting for some more questions to come in, Mark, I have a couple here. When we talk about doing this hot installation, where we're actually putting the data collector, the data loggers, or the split core magnets onto a circuit, you were talking about it was $100 a circuit approximately. But what is it in terms of time? How long does it really take a data center to do this? I don't know. Maybe you can give us an idea of how much time's involved in getting something like this hooked up.
Typically, what we've seen is we start breaking it down into 42 circuit panels. So there's an installation time in the panel. Right now, we're looking at installation times somewhere around 45 minutes to hour and a half in the panel, depending on the application and the structure of that. So that would be a typical installation. And then depending on the output device, we might be spending an hour or two more actually integrating that panel into either an Ethernet protocol or a Modbus protocol. So those are some of the things that we've seen from an application standpoint, both installation and commissioning.
And what about the upfront planning and consulting on this? I'm sure that I know for a fact that a data center person that's online today can contact their Graybar sales representative, and we can get in touch with you. But what kind of mapping or guideline do we want to work on to begin? Do we do an audit of the data center? Do we go in and count circuits? Do we offer some recommendations to the data center owner, operator, the facilities people, so we can map this out and decide what we want to do and what we don't want to do? What's that process like?
Excellent question, Carl. So one of the things that Graybar and Schneider Electric, we're a full hosted supplier that can not only do the field service, the install, the commissioning. Typically what we like to do with end customers is we like to get an understanding of their site, understand where they're growing, what some of their pains are. Then we go out there and we actually count circuits, just as you had said, put together a plan to get our people in and out, see what sort of maintenance window. A dream would be within a data center space if you could actually turn the server rack on or off, but that's typically not the case. So typically we'll work with the split core CTs on a job like that. And then we'll also work with their maintenance crew as far as their facility crew as far as the commissioning and uptime. And we'll work section by section, server by server, and we'll lay it out in a very professional work with the data center. And you know, obviously they have fairly small maintenance windows, so we have to be flexible with their time and their resources.
Robert made this comment, and Robert's clearly has done work with PowerLogic in the past. So he says this: one thing we found to be very important on the installation of a BCMP is to make sure the panel is a normal parallel stack. The tall, narrow panels can be used but are extremely tight and cannot be set up while hot. Do you want to make a comment about that?
Well, I think what Robert might be getting into is, you know, that normal parallel stack. One of the challenges of mounting a CT is getting adequate gutter space or panel space. So when you start using some of the narrow ones, it's very difficult to actually physically get in there, mount the CT, and do that. So I think the situation of the narrow panels is really a function of the amount of room and gutter space that are available on that.
So it's possible if we don't have any room, we'll have to replace the panel?
It just makes installation a lot more difficult, a lot more timely.
So it can be done, it's just a little bit more delicate.
A little bit more delicate is preferred as he had stated to have the parallel, the normal parallel stack.
All right, and he indicated that it's difficult when hot. So does that mean that we might want to do this installation when we're in a maintenance mode, one side at a time?
That is obviously the preferred method, especially with the safety concerns. We actually have field service people that can do some things hot, but we prefer, just like most data centers, if we could get in that maintenance window and work on it not hot, that would be preferred.
And then Mark asked a question here about will this product work in a negative 48 DC type environment?
I haven't applied it in that, so I think I would have to get back to that.
So Mark, we've documented that question. We'll reach out to some subject matter experts that are here with us today, and we'll respond to you via email on your question about 48-volt plants. So we'll make sure that we answer that question for you. Let's see what else we have here. I know this is not part of this briefing, but in my design installation, we combined PowerLink with PowerLogic. I imagine that's okay, isn't it?
Oh, yeah, absolutely, Robert. I mean, the nice thing about PowerLink and PowerLogic is the fact that you have the both products will talk Ethernet, and you can put it on the same. It's a native device within the PowerLogic software. So if you're typically using like a G3 PowerLink panel, you can take information directly out of that Ethernet port and put it on a PowerLogic system. Or if you want, you can do some dedicated monitoring with some software that's available in the PowerLink system. But again, the PowerLogic system, that looks like a native device within the software program.
And Robert reminds us, and this is true, that when we're talking about CTs, they're actually windings, and the data is collected by through induction. So if we're not in an AC environment and we don't have that waveform expanding and collapsing, we're not collecting data on a CT. So this goes back to the DC question. You know, we understand that the CT may not work, but what is the method for DC? So thank you for reminding us about that, Robert, about how those CTs work for the folks that are online. But they are transformers, and they require AC to make it work. But we'll answer the question about DC for the person that asked that. So I'm still waiting to see if there's any other questions coming in. I do have one more. We've seen plenty of announcements here over the last 6 months about structure wear. So tell us a little bit about power logic, data center monitoring and metering like we discussed today, and its connection to the whole structureware scheme. Can you talk about that a little bit?
Oh, absolutely. Good question, Carl. So Schneider Electric has a structureware application suite around the data centers. APC has their structureware operations, which basically gets into a lot of the heating and cooling and operations of the rack systems. PowerLogic has their own version of structureware that complements that basically gets into the power quality, billing, PUE calculations. And what we've also designed within our structureware is a backplane that we can share information across building automation systems, data center systems, power quality and power analytic systems within the data center. We've also taken it a little bit step further, and we've developed a new product that we're actually showing here in Phoenix called Structureware Power Monitoring for Data Centers. So what we've done is we've taken our standard power monitoring suite that we just released, and we have a couple of key things as far as UPS capacity, generator system, battery monitoring, advanced PUE calculations, additional inputs for SCR. So we've actually taken our standard structureware program from a power monitoring standpoint. We've actually customized it for the data center. So as we move forward, what you're going to see from Schneider is a message of connectivity across the various classes, but also be able to provide that building automation owner, manager, that data center manager, that facility engineer, the type of information they're looking at, but also have an ability through web services to tie into those other systems, and when there's an alarm or an event, use the web services to basically look at that. So that's the structureware message that we're putting out to the data center market, and we think that really differentiates us versus some of our competitors who have very good software for their systems but don't have that connected message that Schneider Electric has.
So what we saw today is actually a module or part of the structureware bundle.
Absolutely. So the metering that we have talking to would talk to a structureware power monitoring software, which would be a part of a power monitoring expert software solution. And we also have, in addition to that, SCADA solutions if you need to do not only monitoring, but you also want to do some control. So we have a host of software services and applications for the data centers.
Richard would like to know if you can address real-time remote alert capabilities. Can you talk about real-time remote alerts?
Yeah, I mean, literally, you know, one of the things that we can do from a alarm capability is we can tie into a UPS system and we can see if there's some sort of trip, or if there's some sort of situation there. We can tie into a host of devices. We can get leak detection. We can get fire alarm information. We can get alarms based on power quality. And the nice thing about all the alarms, they go into an alarm record or notification, so we can take that information and we could put out alerts, put it to a cell phone, put it to a pager, put it to an email device. So we can take information from a host of devices that you saw on those first slides that talked about PowerLogic could be your one monitoring system, and we can put that out. So that's how we handle real-time alarms.
Well, I don't see any more questions, so I want to thank everybody for participating with us today. I especially want to thank Mark for being with us today to talk about power monitoring and metering inside the data center. Again, a reminder, you can go to graybar.com, go to G2 Archive, and you can get this copy of this presentation is available to you, along with the white paper, which is very good. If you haven't downloaded the white paper, I recommend that you do that. All the questions that we had today were logged. We'll be back in touch with you if we had one that we weren't able to answer. We want to thank you all for attending. Look for your email. If you're one of the first 50 to be on with us today, you're going to get a certificate for a cup of coffee. And we'll be back next month with another G2 Talk webinar that has to do with data centers. So we're looking forward to seeing you then. Have a great day, and we're glad you're with us today.